We're looking at example 2, section 3.3. And hopefully you've watched the video about the instantaneous rate of change, how we are actually taking a limit of the average rate of change. So, and then there's two definitions. We're going to use the first one for this particular problem. The function, this is a position function given by s of t is equal to t squared plus 5t plus 2. And we're trying to find the instantaneous velocity. And if you remember, if you have a position function s of t, then its derivative, the average rate of the instantaneous rate of change of that is the velocity. So that's what we're trying to find here. All right, so we want to use this definition. We're going to use the first one. The average rate of change, or the instantaneous rate of change here, will be the limit as h approaches 0 of f of a plus h. In this case, it says a, the value that we're interested in is 6. So what we're actually looking for is f of 6 plus h minus f of 6 divided by h. That's the definition of the instantaneous rate of change that you see there. And as I said before, this is actually what's called the derivative, as we'll see a little bit later on. So what we need to do here is find these two values. We need to find f of 6 plus h and f of 6. So f of 6 plus h, what we're going to get here will be whatever I get when I plug 6 plus h in for the t here and here. So if we do that, we're going to get 6 plus h squared plus 5 times 6 plus h plus 2. So that's f of 6 plus h. Now we're going to have to simplify this. Now remember, when you've got 6 plus h squared, that's not 6 squared plus h squared. That's 6 plus h times 6 plus h. That's a binomial times a binomial. So you have to do FOIL on that. And when you do that, you're going to get 36 plus, the middle term will be 6h, then that's the outer term. Then you'll get another 6h from the inner term. So that's going to get you 12h. And then the last term will be h squared. Okay, and then if we distribute the 5 there, we're going to get plus 30. And then we're going to get plus 5h. And then we're going to get the plus 2 on the end there. So that's what we get. Let's go ahead and simplify that a little bit. That's going to get us, let's see, if we combine our like terms, 12h plus 5h, 18h. Let's put the h squared first, so we'll get h squared, 17h on that one, 17h, and then, so that's that one and that one. Then we get 32, and then 36. Let's see, 30 plus 36, 66 plus 2 is 68. So we're going to have plus 68 on that. And then if you find f of 6, that's the other one we need. F of 6 is, as it turns out, 68. If you plug 6 in here, you'll find that's 36 plus 30 plus 2, that's 68. Okay? So what we're doing is we're figuring out what these quantities are in the formula that we have to use. So the limit, what we want to find now, the instantaneous rate of change, is the limit as h approaches 0 of, we just found f of 6 plus h was this quantity here. So we're going to have h squared plus 17h plus 68. And then this is divided by, oh, sorry, I've got to do a little bit more. This is going to be minus, then we have to subtract off that 68. So just so we're clear, the first three terms here, these three terms here, that's f of 6 plus h right here. And then the minus, that's f of 6. So we're just plugging in to that formula right there. And then this is divided by h. Notice what happens here. The 68s are going to cancel. And then, so those are gone. Those two terms are going to be gone. And then if you notice what we have left here, that these terms both have h in them. So we can factor an h out of that. So we'll just go ahead and do that on our next step here. So if I factor h out of that, then I'm left with h plus 17. And then this is divided by the h that was down there. These h's are going to cancel each other out. So at this point, it's fine to use direct substitution in what's left over. The limit as h approaches 0. The only term we have left is this. So if I plug in 0 there for h, I'm just left with 17. And so this is 17 then is the instantaneous rate of change of this object at t equals 6. So the way we can interpret that is the velocity of this object is at 6 seconds, the instantaneous velocity of this object at 6 seconds is 17, and there was no units given on this, but it could be like feet per second, miles per hour, whatever the units of position and time were in this particular problem.